Hey guys, this video is about what is in an atom. Okay, so first of all, an atom has protons, neutrons, and electrons. And I use the symbols P plus, N naught, and E minus to represent protons, neutrons, and electrons. And protons are positively charged. Neutrons are neutral. And electrons are negatively charged particles. So if we go over here, the protons and the neutrons are in the nucleus of the atom. While the electrons are in the electron cloud, outside of the nucleus. All right, so if we look at an atom, all right, so if we look at an atom, all right, let's say we've got a circle, all right, so that represents the atom. The nucleus is going to be a tiny little dot right in the middle. So if you had a football stadium and that was an atom, the nucleus would only be like the tip of a pinpoint or a needle point in the center of that football stadium. So there's a lot of empty space between the nucleus and the electron cloud. And the nucleus is where all the mass is, okay? So the protons and the neutrons have so much mass that the electrons hardly have any. It would be like getting on a scale holding a paper clip. It would add nothing to your mass, to your weight. So that's the way you need to view it. And so the nucleus is going to be positively charged. Nucleus has all the mass and is positively charged. And that's because if the nucleus only contains positive charges and neutral charges, then the positive charges will be all in the nucleus. All right, and then, but the atom itself is electronically neutral because the electrons out here in the electron cloud are negatively charged, and so they balance each other out. So I want to write that down here. Atoms are electronically neutral. And that means that the number of protons has to equal the number of electrons. All right, so let's look at something. If we have this right here, this is called a nuclear symbol. Okay, so let's look at this one. All right, this down here is called the atomic number. And it represents the number of protons. Now this number cannot change. For magnesium, it will always be 12. If it was 13, it wouldn't be magnesium, it would be aluminum, because aluminum has 13 protons. So the number of protons in the atomic number identifies the element. It tells you which element you have. And then it cannot change. So an atom cannot ever gain or lose protons, it has to stay the same. All right, and then this number up here is the mass number. And the mass number is the number of protons plus the number of neutrons. So the mass number represents the number of protons and neutrons in the nucleus. It is not the atomic mass. All right, you cannot get this off the periodic table. Okay, so if I shrink this stuff down a little bit and move it over, let's look at this stuff. And so how many protons would this element have? It's got 12 because the atomic number is 12, and so it's going to have 12 protons. All right, and then neutrons. Since this number represents the mass number and this number represents the number of protons, then that means the difference between the two, so you subtract the bottom number from the top number, would give you the number of neutrons. And so the number of neutrons here would be 13. All right, and then the number of electrons is going to be 12 because this atom is neutral. Atoms are neutral. All right, so let's look at something a little different. All right, we're going to look at what is called an isotope. And an isotope is an atom with the same number of protons but a different number of neutrons. Oops. Okay, so if we wanted to look at these, all right, so let's say we have carbon 14, carbon 13, and carbon 12. All right, these are all three are isotopes of carbon because they have a different mass. So if they have a different number of neutrons, that's going to give them a different mass number. Because remember, the mass number is the number of protons plus the neutrons. And so if their number of neutrons changes, their mass is going to change as well. And so let's look and see how many protons, neutrons, and electrons each one of these have. So the number of protons is going to be 6 because it's carbon, and carbon will always have 6 protons. That number will not change. The number of neutrons here is going to be 8 because 6 plus 8 gives us back 14, right? It gives us back 14. And then the number of electrons, this is an atom, it's electronically neutral, it doesn't have a charge or anything, and so it would be 6. All right, the number of protons for this one is 6 because it's still carbon, but the mass has changed, and so the number of neutrons changes to 7 because 6 plus 7 gives us 13, the mass number. And then the number of electrons is going to be 6. And then the last one, the number of protons, well, it has 6. Number of neutrons, it's also got 6. And the number of electrons is 6. And so our protons plus our neutrons gives us our mass number back. All right, so those are isotopes. And then the last thing we need to talk about is we need to talk about ions. Okay, and so ions have a different number of electrons. And so that makes them charged. All right, and there's two types. First one is a cation, and the second one is an anion. And the cation is positively charged, and the anion is negatively charged. Okay, and so I've said it several times that you cannot change the number of protons. So these guys are losing or gaining electrons, and electrons are negative. All right? And so for a cation to happen, they have to lose electrons. They have to lose negative charges. And for an anion to happen, they have to gain electrons. All right, and an easy, silly way to remember what a cation is, let me move this stuff out of the way. Is, what happened? Well, that's terrible. Let me try that one more time. Okay, so that is the back end of a cat walking away from you. And it's positive. Okay, so cation is positive. All right, so let's look at some examples. So I've got, let's see. This oxygen with a -2 charge, and so that's going to be an anion, right? And then it's going to have 8 protons because it's oxygen, and the number of neutrons is going to be 9, because 9 plus 8 gives us 17, and the number of electrons, this has a 2 negative charge, so it has to have 2 extra negatives, and so the electron number is going to be 10, right? So just so you can see, there's 1, 2, 3, 4, 5, 6, 7, 8, and then there's 1, 2, 3, 4, 5, 6, 7, 8 electrons, and so that is when it's neutral. But this one has a -2 charge, so it has to have 2 extra negatives. And electrons are negatively charged, right? So it has 2 extra electrons. All right, let's try another one. So this time, let's say we've got Chromium 4+, and Chromium is number 24, I believe. Yes. Okay, and then let's say it has a mass of 51. And so what we need to do is figure out how many protons it has. And so the number of protons is always going to be the atomic number right here. The number of neutrons is going to be the mass number minus the number down here, so you just subtract those two. And so that's 27. Whoops. And then the number of electrons is going to be 20, because we have to have 4 extra positives to give this thing a positive charge, so you should have 4 extra protons, and that number can't change. The only thing that can change is the number of electrons. So if you look here and you compare the positives to the negatives, it has 4 extra positives. All right, let's try one more. Let's do aluminum, 3+. And so this one, the number of protons is going to be 13. The number of neutrons is going to be 14, because we're going to subtract 13 from 27. And then the number of electrons is going to be 10. And so when you compare these two to each other, this one has 3 extra positives compared to the electrons. All right, let's try it completely different. Let's try it backwards now. So let's say that we have the number of protons equal to 17, and the number of neutrons is equal to 18, and the number of electrons is equal to 18. So you'd have to use the periodic table, because this would be your atomic number. And so that atomic number is chlorine. And so our atomic number goes on the bottom. And then to get the mass number, you'd have to put that on the top. And so we'd add these two together to get the mass number. And so that would be 35. And then to get the charge, we're going to compare these two. So this time I have 17 positives and I have 18 negatives. And so I have 1 extra negative, and so it's going to be -1. All right, let's try it one more time. All right, so let's say that I have 56 protons. So my protons equals 56. My neutrons, let's make that equal to 59. And then my electrons are going to be 54. And so if I look for number 56 on the periodic table, that's going to be barium. And so I'm going to write my atomic number down here, which is my number of protons. And then my mass number is going to be 59 plus 56. And so that's 115. And then my number of electrons is 54. And so if I compare these two together, I have 2 extra positives, the negatives, so it's going to be 2+. All right, so that's it. That's all there is to it. So you have ions, which are charged. You can have a cation that's positive, an anion that's negative, or you can have isotopes, and they have different masses. So that's why you can't get the mass number off the periodic table. We'll talk about the number on the periodic table, the atomic mass, later on this year. All right, guys, good luck.